All right, there I am. Cool. All right. So, can somebody give me a thumbs up to make sure they can hear me?
I,
Oh,
I can hear you, Brian.
all right.
Yeah, there
All
we
right,
go.
cool. All right. So let's talk about Lambda functions and dynamic arrays, and this will definitely take the full hour. Okay. So, got to hit the right button. All right. So what I want to tell you is why I find these new features to be really cool and why I think they're important. And then we'll go, and I'm hopefully that gets you enticed enough that you're willing to go through the detail of how to do it and what are some of the gotchas that you need to know. So the why. So what is Excel good at? Well, a lot of times we use it for data processes, but it's actually horrible for this process. And what I'm talking about today will help you a little with this because it will help you have consistent logic, but it isn't really designed for this. What is Excel really good at? Is it good at result illustration? I mean, Excel comes from VisiCalc from 1979. Actually, the history of it's kind of interesting. It was made by some math instructors that wanted to illustrate their calculations on a chalkboard. So this is what Excel does well. But what we use it for a lot of times is trying to explain our code. And this is where it's absolutely horrible and infuriating, even though we use it for this, because we think because we can see the results of the calculation, we think that we can show the logic to other people easily. This is not the case. But the whole point of this presentation is to show you that we can have our cake and eat it too. We can have the results illustration, and we can also explain the logic behind those results easily. So let's dig into how that's the case. So business use cases for why you'd want to do this, like product illustration. This is how this comes about, right? I have a third party that does our illustration tool for annuities. And basically what we do is we throw a spreadsheet over the wall, and then that third party has to dissect that spreadsheet and put it into code. Well, guess what? They're slow. And I don't care who you are, you would be slow at that process. It's a slow, tedious process. There's not really many tools to help you do that. Also think about non-guaranteed elements, right? We need to be able to treat different cohorts the same. Otherwise, they may be able to sue us and say, hey, you're treating us differently. Well, that can just happen with Excel's having all this calculation and copying all these formulas everywhere. You could easily be treating cohorts differently and not even realize you're doing it because of the complex Excel logic. Model validation, right? We want to build a library of reusable code calculations that we can use across the organization. And we want to be able to have it, we want to have reusable code that we can put into a spreadsheet so that we can look at those calculations versus the model calculations. And so this will allow for that. And then reduce redundant business logic, right? How many times have we all coded up calculating mortality and calculating interest and calculating this and calculating that? Why not just have a pool of it that we can put into our spreadsheet? We know the code is right, you dump it in, you get your widgets, and you move about your life. So these are the things that I really think this functionality can help with. So moving on. So what are dynamic arrays? So dynamic arrays comes with Excel 365. And what that really means is you can have you have a function that you can put in a single cell, and the results can spill out among multiple cells, creating what basically is dynamic array. And it's dynamic because as you change the function within that cell, the size of the results can expand and shrink. Whereas before you had the concept of arrays before dynamic arrays, but they weren't very flexible and they're very cumbersome to work. That's when you had to hit the Control Enter, and the whole thing didn't work that well. But now they're pretty cool. Now I consider dynamic arrays to be supercells, but it'll take way to the end of the presentation for you to understand why I think I'm going to supercells. But let's move on from here. So what is the actual problem statement? Why isn't Excel good at sharing our logic with other people. So let's look at this formula that I have up on the slide presentation. Okay, you can see, okay, you know that it's a withdrawal penalty, but what the heck do those cells represent? Right? In order to figure out what this function is doing, I'm going to have to go to those cells, figure out what they represent, and then I might have to go to the cells of those cells to go figure out what those cells mean. This is what I call cell reference hell. You just keep going to pointer to pointer to pointer, trying to make sense of what this calculation is doing. And you can't look at this calculation and just know. So what is the ultimate problem with this function? It has dual concerns. It has the concern of calculating your result wrapped up with the location of where its inputs come from. So it's doing two things at one time. And in programming concepts, you never want to do dual concerns. You always want to do individual concerns. So that is the ultimate problem. So how do we get rid of that? Well, what we do, I'll explain later more about this map function, but all you need to know here and now is what we're doing is we've now separated the location of the input from the logic itself. So we can see here that we have a function, and literally and in a map, it's taking each one of these cell references and replacing it and putting it into this lambda function. These are parameters to the function. And a lambda function is just that. It is a function. The first n-1 parameters are just the parameters of it, and then the last thing you put into it is what you want it to do. But now we've solved the problem because we've separated them apart. So the next new concept is a let statement. So a let allows you to define a variable within this function. So in Excel, you could define a variable. You could give a cell a name, but you couldn't give items inside the actual calculation within the cell a name. And so that meant that you had to have a lot of redundant logic within that cell. But now you can name that logic and reuse that logic within the cell itself. And that's what the let lets you do. So you can see here with the let, it just says, I define a variable called no withdrawal, and that no withdrawal is equal to 1. And then the let, then what will the let do? It will then do this calculation. It will do this if condition and decide how to penalize the withdrawal. So now we've talked about what dynamic arrays are and what lambdas are and lets are. Let's see what the cool things that we can actually do with them. Okay, so inevitably, the problem with the problem with the dual concerns is what we want to do is we want to wring out all that logic, right? Because we want to be able to share that logic. We want people to be able to understand that logic, and having to go through cell reference hell to figure out all the logic is a nightmare. So we want to wring all that out. So this is an example spreadsheet that I'm going to be using throughout this. This is a AIG Polaris Max. They sold it like 10 years ago or something. But anyway, this is what I'm going to do. And so this is the example spreadsheet. So let's look using this new functionality, let's look at this code. Because what we want to do is if we create a Lambda library, so we use these functions and we create these libraries, then we can make dumb spreadsheets. And being dumb in this case is a good thing, because you don't need to look at this code in detail. It's not really that important, other than you don't see any logic in it on how to calculate a variable annuity, even though this is the exact logic that is calculating this, what you see in front of you. All you're really doing is just saying, where is the location of my inputs? And then I plop it into my function and I get out my result. So now you've separated the display of your results from the code that actually calculates them. All right, now, because now what that does, if we go a step further, where does that business logic go? Well, it's still in Excel. It comes to this, they have a great new tool called Advanced Formula Environment. And so those functions that exist in this Advanced Formula Environment, that now has a text editor where you can write these functions. And if you just click, come on. Oh, okay. It's not going to let me do it. So anyway, oops. Let me go back. Sorry. So how do we read this? So these libraries can be put in what they call modules. If you think of a normal programming language, we'd probably call them namespaces. But really, it allows you to find areas that have different kinds of functions. So I have functions that are utilities, which I'll explain way later. And then I have functions that are just my variable annuity business logic, which is what you're looking at before you. But where did that logic actually go? Does it sit external to Excel, inside of Excel? Well, what happens is, if you press the save button, where all these formula lives is inside the name manager. So what it will do is it will take your module name and it will put a module name dot in the name of your function. So we can see we have VA dot withdrawal penalty. And so basically this all lives in Excel, but it lives inside the name manager. But trying to do anything of real work inside the built-in name manager would be a horrid nightmare. And so this is where you can go and download this advanced formula environment. This allows you to do this. But it gets cooler than that, because the other thing you can do is you can prototype functions that you want in your library in Excel. So if I hit this little grid button, it'll bring this up to wherever my cell is highlighted. So I had F14 highlighted, and then it will put my function, it'll take that formula and put it in a function template using a Lambda. Now it is kind of clunky. It works okay, but it's better than nothing. But it gets cooler than that, because now what you can do, and this is where the real power is, right? Because now these libraries, now that I've extracted my business logic from my cell references, I can now put that logic into Git. And that is the key. And I can download this Git, because one of the problems with Excel that we've had forever is that we can't version control it, right? We have SharePoint. If you've tried to use the SharePoint version control, that's a horrid nightmare. It kind of randomly does stuff. It's kind of hard to document. Yeah. Now this, I get the full power of GitHub. I can basically put my code up in there, and I can version control it, and I can track all the changes and whatever. So now it allows us to be able to use a spreadsheet among multiple people, look at all the changes, and we want it, we download it. And this is how we can share logic across the organization. We put it in GitHub. We test the kajibis out of it. It's now the official version. We download it, we put it in our spreadsheet, and everybody can be confident it works and it's version controlled. And life is good. It's not letting me do that. Okay, so moving on from there. So then once you have the logic extracted, what you can do is you can put that logic in ChatGPT. You can literally go say, convert Lambda expression, Lambdas from Excel, and put into a class called Polaris Max. And voila, what we can do is we can take this, well, we can take that Lambda library. So you can see this code here. And then what we can do is we can create a prototype in another language. So for example, my third-party illustration guy, he might be using Python, he might be using C#. I don't really care, right? What I can do is I can take that Lambda library, take a large language model and convert it, and it quickly changes it to the language that he uses. And now I have an Excel, and we have a way that we can rapidly prototype stuff. Now, you never want to take code out of an LLM and drop it in your stuff and go to production. But what it does do is it takes away, because there are no tools that will allow you to see the logic and transform and also transform that logic to a new language so that other people can use it outside of Excel. There is a concept called coherent, but they take the spreadsheet, compile it in C++ that you can never see, and then you pass around an API. But you can't have it where you can pass around the code and put it in a new language from the Lambdas, and everybody can see it, and they can see it in the language that is native, and create the rapid prototyping. Because that's the whole problem with the third party. That's the problem. They have to go through those cell references to figure it out. Well, now if we write everything in Lambdas you can get rid of the cell reference problem, and now you're faster to market. You're faster to market. So they can create a prototype. And so that's what I've done here is I went to ChatGPT, took the lambdas you saw, quickly converted it to C#, and then I was able to just take the input, create a for loop around the input, and then each function that is in my lambda becomes a function in C#, and I literally can then have this, I can literally create this prototype, and now we have a rapid way of getting logic across the organization and using it without it being buried in Excel. And we can create quick prototypes. So why is this so great? Because like I just said, we can separate logic from cell references, makes logic easier to understand and shareable. We can create reusable library components because we don't need 50 actuaries making 1,000 different calculations all ourselves, and they're going to have thousands of errors. We can create one library that we're all confident in, we know works, plunk it into our spreadsheets, use it for model validation. Life is good, right? We can use GitHub for version control, so we can version control all our business logic inside of our spreadsheets, because that's one of our massive problems we have. Like I said, I just showed you that libraries can be easily converted through other language, through large language models. Now, not perfectly, but good enough that you can use the tools that already exist to take it the rest of the way home. And so, and get rid of the time-consuming part of the actual time-consuming part. And then also we can use unit. So the one thing we also can't do with Excel is everything that we test in Excel is in the calculations that we create. But now that we create independent functions, we can test those functions independently, because everything fails when it hits a boundary, right? It's either this on this side of the if or that side of the if. So we can test all our functions independently, making sure that with it they properly do what they need to do within their boundaries, and we can test that independently of the calculations, and then we can also make those part of calculations, which is something we could never do in Excel before. So there's a lot of fun stuff, and makes Excel much more like a formal programming language than what it was before. Okay, so now that I gave you all the cool things you can do with it, and I hope that I enticed you to want to dig into this after the presentation, now we need to get into the how. Okay, so warning, actual calculations with this new functionality will likely cause circular references. And I'll explain why that is. That is not a bug. That is a feature of where it comes from. But I'll teach you how to deal with it so that doesn't stop you. But this is not a bad thing. This is actually a good thing. But I need to explain to you why. But our whole goal is how do I eliminate those circular references so I can use this for everything? Okay, but to understand how to do this, you have to understand programming paradigms, because you have to understand what inspired the Lambda libraries and the dynamic arrays in the first place. And the other thing that you really need to know is the formula auditing and the dependency patterns among it. So when you go to formula and you find that dependence or precedence, that actually becomes the patterns that you see in those dependencies become really important to understanding when the cell references will occur, and that's what I'm going to show you today. So let's talk about different programming paradigms. So the first paradigm is the structured paradigm, and that is the old classic. It's from like VBA, Fortran, C, and basically structured programming is programming in terms of a list of operations, right? I want to do this, and then I want to do that, and then I want to do this, and then I want to do that. And when you get everything done, you get the result that you want. Okay, object-oriented programming is the concept that I create classes. And object-oriented programming is programming in terms of responsibility. So I give these classes different responsibility, just like if I was a manager, I have different team members and I give them responsibilities. And what they do is they communicate back and forth. And when they get done with their process of communication, you have the result that you want. But what the Lambda expressions are derived from is from functional programming, such as Haskell, F# or Scala. And so what functional programming does is it creates objects and then it uses functions to transform those objects to get to its final result. So it's a far more abstract way of even thinking than object-oriented programming, but because of that, it has some beautiful outcomes and is very, very expressive. Okay, so moving on. So now we need to learn what are the functional programming fundamentals. Okay, so when it comes to, so here are the 6 different properties of functional programming. First of all, you have the concept of a pure function, where whenever I give, and a pure function is, think of it like a mathematical function. If I give you the same x and I give you the same y, I'm going to get the same result back, which is not necessarily true in a structured paradigm or object-oriented paradigm, because you could have this global variable, right? And so I can give you the same x and y, but you may get a different value because this global variable off somewhere else is causing this. So but in functional, you have pure functions, and that also makes it better for actuaries and testing, because I know if I give you a function, it's going to always return the same thing, so I can be confident in my test. And that's what they call it. A pure function doesn't have side effects. The next one is immutability. So unlike a structured or object-oriented programming, where, for example, you can have a for loop where you can have a variable, you can say a equals 1, and then you can say a equals a plus 1. You cannot do that in a functional language. It means once you declare a variable and you give it that value, it is that value forever. So if you look here at the upper right, if I said a equals 1 and then I said a equals 2, Excel is going to say you can't do this. This is an error, because you're trying to mutate the same variable. Now, the next one is functions as first-class citizens. So what this means is, just like you can declare a variable int or double inside of a language, in a functional language you can declare a variable as a function, and a function is fundamental as an int or a double. It has it's just fundamental as those primary language features. The next one is higher order functions. And higher order functions say that functions can take functions as parameters, and functions can return functions. And the other one is function composition. I can take many different types of functions and I can compose them together in different ways to produce a result. And then you have the concept of a recursion. So in an object-oriented language or a structured paradigm language, if you want to loop through something, you have a for loop, right? And you always say for I equals 1 to whatever, and then for each iteration of the loop, you increment the I, and then when I hits a certain value, you stop. We have a problem in a functional language. We can't do that. We can't increment I. So how do you loop in a language that doesn't allow you to increment that variable that you've always put in your for loop? Well, you have to have recursion. And so a recursion is just a function that calls itself. And so I will be taking you through examples of recursion here shortly. So let's look at some examples. So right here on your screen is the concept of a Newton-Raphson. And the Newton-Raphson is just a numerical analysis function. It's just a goal seek. That's really all it is. And what the Newton-Raphson says is if I can give you a continuous function and I can give you its derivative, then I can recursively go and find the root of that function. So if we look here, and so we can see this as a recursive function because we can see that the Newton-Raphson is calling a Newton-Raphson. It's calling itself. So there's where the recursion comes from. The higher order function is the function that's being called. So right now, the function that I'm trying to find the root of is x minus 1 squared. So if I give it a lambda, which is the function x minus 1 squared, and I give it a second lambda, which is the derivative of x minus 1 squared, and I put that in there, then I can go and I can find what is the root of that function, which is obviously 1. And so the nice thing here is but I don't want to just do it for this function. I want to do it for any continuous function. So I can create lambdas of the function and its derivative that I want, and I can reuse them. So here is a higher order function because the function I want to take the derivatives are functions to my Newton-Raphson function. I've used the word function way too many times in there. But anyway, so that's and then function composition is I have the absolute and I have this is omitted, and I have this is omitted function, which is composing different functions together. So that's kind of the properties in general. So let's go even a step further. So let's go. One of the things that came with before I can explain to you recursion, I need to explain to you these important Lambda helper functions. And these are great. And these will come in any functional language. Okay, so we have the concept of a map. And a map is exactly what it says. It's just going to take a list of parameters and it's going to map it to some result. So for example, if I take x and I y and I say x plus y equals whatever, then the x and the y are getting mapped to the operation of addition and you're getting a result. A reduce basically just takes a list of numbers and compresses them down to a single value. So the classic thing in Excel is like the sum function or the product function, right? I'm just going to take a list of numbers and sum together and slap them up to an individual result, right? Or the product, right? I'm going to take a list of numbers and multiply them together and come up with a result. That is essentially a reduce is just a generic form of the sum or product. The scan function is a running total. And the easiest way I like to think of a scan is if I wanted to debug my reduce and I wanted to see each item of that reduce as it accumulates up until it reduces its volume of value, that's what I would use a scan for. And when you use actuarial illustrations, you will always be using some type of scan function in that thing. So become very, very accustomed with the scan. An H stack is what it's saying. It's a horizontal stack. It's just stacking columns. It's just stacking columns together. A V stack is a vertical stack. It's just stacking rows together. Because you define these dynamic arrays, you can have different columns from different parts of the spreadsheet, and you can stack them together and make them their own little individual little dynamic array to work with. A drop will drop the items of an array. A take will take a certain number of items of the array, and then the is omitted basically says if I have a lambda function and I omit one of the parameters, then this will tell you it's true that that parameter is omitted, so that just like you saw before up here, I'm saying if this parameter tolerance underscore is omitted, then say my tolerance is 1 basis point, otherwise use the tolerance that I gave you. All right. So now that we have an idea of these functions, we're going to go use these functions a little bit. And so I'm going to show you some recursion now. So there is a great YouTube channel from this gal that I highly recommend you go to. So sometimes when I need some review, I go to her channels and she explains stuff really, really well. But I'm going to take her example from her website on how to make a recursion function, and I'm going to use her as an example. So all she tries to do is, if you take this middle column, right, she has the name of stuff, but she doesn't like the name. And so what she wants to do is change it into the value that's on the far right. And how does she want to do that? Well, she wants to so she looks at this matrix off here on the right where the before is, and she says, okay, if you find anything with the name before in it, I want to change it to what's in the after. So basically, if you find something in the skills that has something in the before, I want to replace that string with something in the after. And she does this with recursion. But I'm going to show you my method first, which accomplishes the same thing, and I'll show you hers, but there's a good reason why. So let's look at recursion and purity. So if we look at this I call it the mega replace fix, and I'll explain that later. But the Lambda here takes the text. So if we look at the example, it's taking what's in the skills. That's what you see down here in the bottom, this text input down here. And then it takes in the before array and the after array. So it takes in the attire and column before, and it takes in the after column. Okay. And you can see that because, as I point out here, this is the text, this is the starting value. It's going to take the before array and after array. And I want you to look at this function because, as you can see, there's nothing in this function that once I receive these parameters that I go out to the external world, right? This is pure because it will always return me the same result if I give it these array in this text. But how this works is, on the first step, what we do is we take the first item of the before array and we put it in the BF variable, and we take the first item of the after array and we put it in the AFT variable, and then we put those into the substitute function, and then this allows it to substitute it, and we produce our new value. So we've defined three variables here: Bef, F, and V. And then we say, okay, if the number of elements in the before array, and there's 7 in them currently, minus 1 equals 0, but this equals 6 right now. So then what we want to do is we want to call the function again. And so what we're going to do then is we're going to take the result that we created, we're going to put it back in the function as the new text, and then we're going to drop an item from the before and after array. So something like this. So now the answer now becomes the new value. You then look at the before and after array, and then you start, and then you can see that the PowerPoint with a space is changed to PowerPoint without a space, right? And then we go down and we keep saying, going down, and we drop an element from the array, drop, drop, drop. And then once we get to, we've dropped all the items of the array, we pass back the V, and that gives us the final answer. And so that's an idea of recursion where I'm looping through, and I'm by calling the same function, which we don't have with cell references. We don't really have a loop without a goal seek, but here we can now loop. So now I want to show you what she did in the video. And this isn't to bang on her. I think she did that video before the Lambda helper functions existed. But it's important to look at her implementation versus what I did. Because rather than taking in the array, she took in just the first 2 items of the array. And then what she does is, if you look here, she takes those items and she finds the location of them. She offsets it. So her offset is equivalent to my drop. And then she offsets it. And then when she says, hey, when I get below the last, before I get to, once I get to one cell below the array and it's blank, I want you to stop the recursion. Well, there's a problem with that because it's not pure, because she is having to look at the outside state of the world, which is whether the cell below the before text array is blank, and also she's offsetting using cell reference. She's looking at the outside world. If you look at the outside world, that's impure, and that can cause side effects. And so we want to avoid that. So I want to say this, there are times where Excel tries to make things easier, but it actually inevitably makes it harder, because even though it's inspired by functional programming, Excel doesn't necessarily enforce those things. So you can break those rules, but if you break those rules, in the end, you're going to cause yourself more pain. So I recommend that you always make sure that things are pure, and once you bring in the variables, you are never asking the external world anything else, so that you're not dealing with side effects. Because the problem is, if I was to reuse this function in another spreadsheet, and let's just say I had something butting up against the before text cell, this is going to cause an error. This won't work in different spreadsheets because it has a potential side effect. Whereas mine, I give you the ray, I tell you exactly what the ray is, and I never look to the external world to figure out when to stop. It's pure, and so it's far more reusable. So that's why I don't care for her implementation, but that's the difference between purity and impurity. But there's actually a way that we can prove upon this. So this will produce the exact same result, but this is slightly better. And the reason it's better is because we are not doing the recursion ourselves. Because if you're going to make an error, you're probably going to make an error in the recursion. So you want to use the built-in helper functions as much as you possibly can. And so not writing your own recursion for it. But there are many times in Excel where you get stuck due to some limitations I'll explain at the very end, that you're basically forced to reduce the recursion yourself. But if you can use the built-ins, I highly recommend you use the built-in. So let me show you how I would do it with built-in functions. So we need to look at this as this is really two functions together. So the inner function, let's look at that first. Okay, so it is creating a map, but what is this map doing? So this map is taking the before array and after array, but if we look at this weird thing in the middle here, this lambda is actually, so this function is actually returning a function. So this is a higher order function, a function that returns a function. So what does this function look like? So it's going to take this, it's going to take the first item of the array, and the second item of, it's going to take the before array and after array, and it's going to create a function of one parameter that takes a text, and then it returns a result of text. So I'm basically taking two strings and mapping them to a function that takes one parameter. Okay. And so when I do that, so now when you look at this reduce, when it returns, you'll have a list of functions that take one parameter. Then what happens in the reduce is a reduce it starts with a starting value, because basically a reduce, you're trying to reduce this down to a single value. So you have to start with a starting value. Just like with a sum, you would start with 0, or if you're doing a product, you'd start with 1. Same idea here. You have a starting value and you want to reduce it down. And so what you're going to do is, and this reduce, in order to describe how you should do the reduction, it also needs a lambda. But what you're going to do is, this lambda takes the previous value plus the current value, and then allows you to return a result on the previous plus the current. But what we're going to do is we're going to take our previous value is going to be the text of the previous step, and our current one is going to be our function. And then what we're going to do is we're going to take that function, we're going to put in the text that we want to improve, and then that will return the result. So then what will happen is it will look like this. Inevitably, the reduce will look like this. It will take this input. It then has its lambda where it puts in its text. It calls the function that the map created, because these values that are not highlighted were already there. It puts in your parameter, and then it gives a final result, and then it walks down like this. Boom, 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 until it does the final result, and that would be the result that you had before. So all three of these methods I showed you accomplish the same thing in different ways. And then if you wanted to do a scan, if you just change the reduce to a scan, the only difference would be the result would be the entire column on the right, as opposed to just the single value at the bottom. So now we've looked at higher order functions, we've looked at recursion. Now we are all stooped in functional programming. All right. So now this is where we get to the meat and potatoes. So this is where so when Excel does its formulas, what it does is it will take all your formulas and it will create underneath the hood, it will create this giant tree. And then basically it will do a depth first search, and it will basically walk up the tree until it gets to the value at the top, and that's the result that you have. And if at any point in this tree, you have two different functions. If it how much is if the calculation points to the same node twice, then you have a circular reference. And that's how it basically determines a circular reference, because it needs to have this, it needs to be able to roll everything up. And if you have a circular reference, it can't do that without some type of solve. So this is generally what's going on underneath the hood. Okay. So I want you to look at these dependency patterns, but know these calculations are garbage. What I want you to they're the same approaches done different way. One in classic and one in what I'm calling the new Excel. So pay attention to the difference in the pattern, not what the calculations are doing, because they're just dumb, just for illustration purposes. But if we take a simple classic Excel example on the left here, and we look at a map, right? We're just going to take two variables, two values, and we're going to map it to a new number. You can look at this dependency pattern. Boom, boom, boom. 3 plus 4 equals 7, right? We're going to map X and Y through addition to come up with a value, right? Very much intuitively what you would expect, right? And the scan is a running total, right? So if we look at trying to program an Excel and a scan in classic Excel, it looks something like this, and you get this what I call the sawtooth pattern. So if you wanted to read this, you'd say that 3 minus 0 is 3, and then you'd say 4 minus 3 is 1, and then you'd say 5 minus 3 minus 0 is 3. 4 minus 3 is 1. There we go. 5 minus 1 is 4. 6 minus 4 is 2. And so on and so forth down the row. Okay. But now we look at the same exact formula, but now we've coded it into our Lambda. We've coded into our Lambda expression. But why did the dependency pattern change? Just because I put in a new function, isn't it ultimately doing the same thing? And I'd say yes. But this is where understanding functional programming is very, very important to understand why that dependency pattern changed. And that's because the reason that the dependency pattern starts at the top is because essentially this is the idea of the immutability. In other words, once you give me the values, they can't change. And so the dependency starts at the top, and if anything within this dynamic range changes, any one of these cells, then it's going to give you a circular reference. So it is the concept of the immutability that is changing the dependency pattern, which unfortunately is ultimately causing the cell references. And this is why I call a dynamic array a supercell, because the way to keep this keep track of this in your brain is in Excel, the cell is the atomic unit. And so even though it is a supercell and it spills into other cells, if any one of those other cells that it is working with refers back to has other calculations off in the spreadsheet and comes back and refers to that cell in any way, it's going to cause your circular reference. So that's why it's so important that you understand the dependency patterns of your calculations, to understand why in the world when doing this you would be getting fits with circular references. So let's break this down a little bit. When does it actually happen in an illustration? Because this is why I used it on a variable annuity, because in a variable annuity, right, inevitably you're going to have an account value, and you're inevitably going to have a benefit base. And guess what? Those account values and those benefit bases interact together. And when you do that, if you put those calculations into different cells, they're dependent on each other and they break the immutability. So the real pattern that does it is exactly like this. I have an account value, right? And then imagine this dependent on account value as a benefit base. And they're going to come here to my withdrawal penalty, and then I'm going to use that withdrawal penalty to figure out what my new benefit base is. So once you kind of get this V in triangle, this is when when the dependency pattern looks like this is when you're going to get this is when you're going to get the circular reference. Now, when I mean dependency pattern, if you code this up in classic Excel first, and you're saying, I want to convert this to dynamic arrays and Lambda functions, when should you know that you're immediately going to run into circular reference problems? It's whenever you get anything like this. And I call this the functional triangle because that means this is when functional programming has the idea. I thought about calling it the death triangle because it's the death of thinking the way of classic Excel and having to think of a new way. Or I thought about calling it the circular reference triangle because anything that you try to use functional programming in Lambdas with this triangle type of pattern would cause a circular reference. I don't know what the right one is, but at the end of the day, this is the pattern. So if we go look at this if we go look at the variable annuity that I've been using as the example, you can see this V. I know this is a lot to look at, but if you look here at the assumed contract value, and then you go look at the income base, and then you go look at the withdrawal penalty, it goes off to the right, which modifies the income base, and then it goes down, blah blah blah. And this is a very, 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 very common pattern in actual calculations that you will not be able to avoid. And so guess what? You're going to get circular references. So how do we solve that? Okay, so back to here. So how we solve that, if you go back and you look at my example, why did I have an individual function, and I had this big function that it did all these things at once? Well, the reason that you see all these calculations in that one function is because that's because of the dependency pattern I showed you in the previous. If any of these are outside of, or if I try to divide this up into different columns to simplify the problem, I immediately get the circular reference. So this is the thing that baffled me when I first ran into this, right? Because if you think classic Excel and you said, I have a problem that's too complex, I'm getting circular reference, what's your gut reaction going to be? Your gut reaction is going to be to divide it into more columns. But that's not going to solve your problem. You're still going to run into circular reference. So how do you solve the problem? You start compressing them into the same cell. Well, if you tell me in a classic Excel example that my problem is too hard and I'm going to start consolidating into one column, I'm going to tell them you're out of your flipping mind, because that's just going to make the spreadsheet horrible. But I just said, all right, I'm going to deal with this, and I'm just going to see what the results get me, and I'll deal with the results when it. So I started compressing them down. I was able to eliminate the circular reference, and then I would realize, wait a minute, even though this is creating one large function, I now can divide this into individual functions. Wait a minute, now I'm creating myself a library here. So what once was ugly now became beautiful. And so that's how it did it. But you have to but that's what made me think about the Lambda library, is seeing how those functions aggregated. Now, this being said, you don't have to, once you run into that V pattern, it's not like all calculations thereafter have to be within this one large thing. You can see that this protected income payment does use a result based upon this thing that had this horrid dependent pattern, but it's not involved in that dependency. So you can extract things. So you only want to make as stuff as, put as much stuff as, you still want to minimize the stuff in one cell, but you've got to do it based on the dependency patterns that you have to reduce the cell, to make sure that you're not getting the circular references. All right, and I'll come back to these boxes later, but that's generally what I'm doing and why it's structured the way that it is. Okay, so, and then when you get done and you fix this problem, you get right back to the dependency pattern that we had. Because once I change this from the classic way to using Lambda dynamic arrays, this gives you the same dependency pattern as if I use just a built-in function map or whatever. So the good news is we have a lot of cool stuff that we get with what seems to be a very simple functionality. But the problem is, it means your programming chops have to level up, because you have to be able to think in functional programming, and most of our like VBA is structured in most of the ways, and all actual calculations are usually using a structural paradigm. So you have to be able to think differently. But So now I'm going to give you some more heartburn. So like I said, Excel is inspired by functional programming, but it doesn't follow its rules really closely. It allows you to break those rules. And sometimes you think flexibility is good, but sometimes flexibility is actually bad. It actually causes you more problems than it solves. That's what I call Python. Anyway, so let's talk about this. In a functional language, there is a concept called, in a functional language, there's a concept of a list and a tuple. So a list is an array of things of the same type, and a tuple is a collection of things of different types. Okay, so imagine I have a policyholder, right? And a policyholder has an issue age, a gender, and a premium amount, which would be an int, a string, and a double. Well, I'd have to put that collection of items into a tuple because there are different types. And then if I wanted an extract of policyholders, I would put that tuple of int, double, and string, which become its own type, into a list. So I'd have a list of tuples, and that would be my policy extract. The problem with Excel is that it combines the concept of list and tuple together. So what seems like a blessing is actually a curse, because this actually complicates your life. It doesn't make it simpler. Why? So remember when I had to go back? Remember when I was doing that recursion and I showed you this crazy map function that takes two values and maps to a function? Why did I do that? Why didn't I do something like this? Because this would have been a heck of a lot easier to just say, give me a starting value, give me the array, the before and after array, and then do the substitution. Well, the problem here is the reason you can't do that is because when you give when you give Excel the array, it treats the cell as the object. So if I give it a two-dimensional array, it's going to want to go through each item independently and walk each one of those independently. So right, when I'm doing that before and after array, if let's say I gave it an array with two columns and three items, right? So I would want it to do three operations, but what the built-in functions do by default is it would want to do six operations. It would want to do one for each one of the elements. But I need the before and after to work like a set. And that's what the tuple provides me. It allows me to take things and things, whether they be the same or different, and define a set. So in the previous example, my set was a policyholder, which you had an age, premium amount, and sex. In this case, my set is a before value and an after value. So the reason I had to take these two values and turn it into a function is because I'm taking two values and turning it to into one value, so that when this reduce works, it just has a single array it has one column and three items, or it was seven or whatever, as opposed to working with each item differently. And that's the problem of not having the tuple, because I have no way of defining a set. And so the problem is, whenever you run into that problem, you're back to rolling your own, and you have to build your own recursive functions. And so that's why I had to show you recursion, because there's essentially no way to avoid it. The other problem that you run into is that so I told you I'd show you what these red boxes are for. If you look at an actual illustration, right, I'm going to have multiple previous values. So if we look at this variable annuity, I have a previous cash value, a previous income base, a previous income credit base, and a previous mall, right? And I need those previous values as I go through this. I can't deal with them in individual items. I need all four of those to be able to walk this thing forward. Well, the other problem you run into is that if you look at this scan function, you see that this is an initial value. And then what it means by value is it means value. It means an int or double. And it sure as heck does not mean an array, because I tried everything under the sun to make this work with an array, because that's what I need to use built-in functions, and I couldn't do it. And so I was back to having to roll my own. So again, some things that it thinks it makes simple, it makes harder because it doesn't stay to functional programming close enough. And so these are things you're going to have to watch out for. It doesn't mean you can't use it. You just have to know these are the booby traps and how to manipulate it. And so hopefully I've shown you how to manipulate it. Okay, so the bad. So conclusion, it will require actuaries to increase their programming chops. And you're going to have to think differently because you're taught to think in terms of an order of operation. I need to do this and do that, whereas now you have to think in terms of function and functional programming. So this is, again, is leveling up the programming chops. But the good is, the whole point is I want to speed up my logic and my communication. And now I've been able to separate my logic from my cell references. I can separate the presentation of my calculations from the calculations themselves. That makes the calculations reusable, translatable. Life is good. Also, because we're able to define these things in lets, it actually makes the Excel calculations much faster because I don't have to have 1,000 VLOOKUPs, right, all down my row. If I need to just look it up, I can look it up once and it's done because I can reuse the value of the lookup. So I get a tons of reuse. It speeds up Excel. It allows me to version control Excel, which is good. But even though it requires actuaries to increment up their programming chops, it's not a bad thing. Being able to look at things from different paradigms in different directions is always a good thing because there's some times where some paradigms are easier than others, and being able to see when and how to adapt what you need to do based on those paradigms allows you to more quickly solve problems. So it's never a bad thing that you being able to look at problems from different dimensions to be able to solve them the best way. All right. With that, I am done. I'm going to unmute everybody, and let's see if we can take some questions here. Let's see if I can figure out how to unmute. Share screen. Okay, so I think I've done this. Okay. Can somebody unmute and say hello?
Hi.
All right, good. Now I can hear. All right, great. So does anybody have any questions? I know I threw a lot at you in little, and we got 3 minutes, but what can I answer?
So I have a question. Like this all was very interesting. I did try the lambda and let functions, but then what I really like about this is that you can have all the business logic separately. But I want to understand before I am a tech savvy person, but have you tried like build worksheet, spreadsheet with this? How was the adoption of people around you in your workplace for this?
So I'm in that process right now. So
Okay.
I was working with this so much to make this presentation. I'm getting to the point where I can't stand to work on something unless it has this. And guess what? Nobody else in my group has the skills. And I'm also having to work with students. And so the adoption is slow, right? We all want to do our own things, but what I've tried to do in this presentation, and the same thing that I have to do, is I actually make this in classic Excel, and then I will put it in the functional programming because I don't think functional programming off the top of my head. And so a lot of times what you're going to be doing is you're going to have to be converting. And adoption is slow, and getting people to learn things and think about things and deal with circular references when they never had to, it's brutal. But it's also the nature of the beast. To me, it's much easier than learning Python. Um, yeah, to me, it's much easier. And so it's just, what are you willing to learn? But the adoption is hard, but it's always hard for new technology. But I'm trying.
I'm the only person using it that I know of besides you, Brian. And I have not written a Lambda function yet. AI has written them all. So the programming charts part, it's really, can you write a tech spec to AI and specify clear variables or name ranges? Hopefully that's encouraging because I don't actually see a list of bads on the conclusion.
I had somebody else tell me that they were using ChatGPT for a lot of programming and to figure out what the lambdas are. I don't know. I'm old school. I got to do it myself. Now I do go to sometimes and say, can you simplify this for me, or can you follow this pattern? But I've never said from scratch, here's my description, build me a function to do that. I've never done that.
My first one was Black Scholes, and I had it all messy in Excel, and then I converted it for all the reasons that you described, because it just got easy to follow. And I think I did do that one by hand, but for the recursive stuff, I didn't even understand why any of that worked until your presentation here. So good work. But I've been using recursion.
Brian, I have a question. So this kind of ties in with Pooja's issues about trying to get people to adopt new things in the workplace. You showed, I think version control is great, and the way that you can centralize functions, putting all those Lambda functions onto GitHub is great. But you say that it increases the auditability, but you're writing in Lambda functions, and the people who operate our corporate governance, they can't really read Lambda functions at all. So it's like, how can we move towards this, away from these thousands of Excel formulas and hundreds of Excel workbooks when people don't have those skill sets to move, it's like, how do we, it becomes a question is, how do we actually increase people's programming chops?
Okay, but here's great. When I'm sitting here and I'm programming something and I'm saying take the pattern out of something or replace the pattern, the ChatGPT is actually explaining my own function to me. It actually, as you do it, it actually will document some of those functions. So I'm wondering if we can go to ChatGPT and give it a little bit of context, and it can, and say, could you put this function into terms, and see whether it could do it, because it kind of has done it, and I'm wondering if that can do it and document it. But this is much easier because we can compress all that logic across the entire organization much. We can compress it down considerably, and then we can make it much easier to do. And then maybe we can have ChatGPT analyze it and give us back results to say, okay, generally this in context, this is what this would do. You're having me experiment with that. I think that's I see the challenge, and I think I'm gonna go play with that as soon as I get off here.
It does a great job of commenting your code and adding debuggers if you have pre-existing code. It will also reverse engineer. And I'm using Perplexity mostly because it does have GPT as an engine, but it gives you footnotes as to where it's getting its information from. But it's
Yes, I started using
super
Perplexity
powerful.
too except for that exact same reason.
Super powerful. It's a matter of, can you think clearly and like boil these things down into that functional architecture?
Yes. All right, I'm way over time, but this is fantastic. And if anybody wants to talk to you about this stuff, email me. I will talk all day about it. It's fun stuff. So I hope you enjoyed the presentation.
Thanks.
Yeah, thank you.
You're welcome.